Alright, alright, in this video we're going to be going over investigation 3.3.2. So our focus question for today is, what are the three methods of solving the equation? So this lesson is going to be a little repetitive. We're going to be solving the same equation over and over again, but each time we're going to be looking at a new way of solving it. So this first method we're going to look at is called rewriting. So if I start off with 3 parentheses x plus 2 equals 15, how can I rewrite this part right here in order to solve the equation? So one of the methods that we've been learning over the past few days was distributive property. So I could use the distributive property to rewrite this. I can think of this as I have x plus 2, I have 1 x tile and 2 squares, and I want a height of 3. So 3 rows of x plus 2, 3 times x plus 2. Notice that I have 3 x's, 3 rectangles, and I have 3 times 2 is 6, I have 6 squares. So 3 rows of x plus 2 equals 3x plus 6. So now let's go into solving the equation. Notice that the same tiles appear right here. So again, I converted 3 groups of x plus 2 into 3x plus 6. And now we can solve this equation. The first step in getting x by itself is getting rid of everything next to x. So let's get rid of all 6 of these tiles. I'm going to subtract 6 over here. But whatever we do to one side, I need to do to the other side. So let's get rid of these 6 as well. Minus 6. So I'm left with 3x equals 9. So what's left, since I have multiple x's, the next thing I can do is divide this into 3 groups. So I can divide this into 3 groups. But if I divide this into 3 groups, I need to divide these into 3 groups. Okay. So divided by 3, divided by 3. Looks like x equals 9 divided by 3 is 3. One of these x's was the same as 3 of these squares. So that was our first method, rewriting. But there are other ways of solving this equation. Our second method that we're going to look at is going to be undoing. So here, instead of using our distributive property, we're going to start by undoing each of these parts in front of the x. So here we know that 3 parentheses x plus 2, this is 3 times x plus 2. So the way we can undo multiplication here is by dividing each side by 3. So here, let's divide these into 3 sections. Divided by 3, divided by 3. So after dividing both sides by 3, I'm left with x plus 2. Oops, x plus 2. And over here, 15 divided by 3 groups, I'm left with 5. So all that's left is to get x by itself. So let's get rid of these 2 over here. All right, but if I subtract 2 from the left side, I also need to subtract 2 from the right side. So let's get rid of 2 over here. So I see that 1x balances out with 3 of these squares. So x equals 3. All right. Finally, our last method is going to be looking inside. So let's go ahead and ignore whatever's in here. Let's cover that up. And let's pretend we have this problem here. 3 times something equals 15. What number is going to complete this problem here? 3 times what equals 15? Well, I know that 5 could complete that problem. 3 times 5 is 15. So that means whatever's inside here, looking inside, has to be equal to 5. Since I'm able to swap out the inside with 5. Since I'm able to place 5 inside here and complete the equation, whatever's inside here has to be 5. So I have x plus 2, whatever's inside, has to equal 5. So solving for x, I can subtract 2 on both sides. I'm left with x equals 3. Again, notice that no matter what method I picked, I got the same answer, x equals 3, the same answer, x equals 3. So despite these different methods, we still got the same answer. So let's go and take a look at the next example. So first step, let's try solving this using distributive property. I have 2 times x plus 3. So I have a rectangle piece and 3 squares. And I'm going to double whatever I have here. So 2 groups of x, 2 times x, I have 2 x's. 2 rows of 6, 2 times 6, I have, 2 rows of 3, 2 times 3 is 6. Okay. So now when I switch over to solve equation, notice that I have 2x plus 6 right here. Right? That's what I distributed it to. So I have those tiles. So from here, to get rid of positive 6, Another way of getting rid of positive 6 is by using negative 6 to cancel it out. So I can use negative 6 to cancel out those positive 6. Then I can also use negative 6 over here to cancel out this side to keep it balanced. Okay. So let's drag over 6 of these red tiles to balance everything out. Oops. 2 more. Okay. So now I'm left with minus 6. Notice that these positive 6 and negative 6 cancel out, leaving me with 2x. And then 4 minus 6 equals negative 2. So from there, since I have multiple x's, the next thing I can do is divide this into 2 groups. Let's split up these x's, divided by 2. But whatever I do to one side, I need to divide these into 2 groups. Divide these into 2. So divide by 2. Divide by 2. X equals negative 1. All right, so now we're going to take a look at the same problem, but this time we're going to use a different method of solving it. So this time we're going to solve it by undoing each part. So first let's undo this multiplication in front. So to cancel out times 2, I can divide by 2 on both sides. All right, what that looks like is I'm taking each of these groups and I'm dividing it into 2 sections, leaving me with x plus 3. And over here I have 2. 4 divided by 2 is 2. So finally, to get rid of these 3 positives, I can use 3 negatives. So let's cancel those out. But if I minus 3 on one side, and then you put 3 more red tiles on the other side. So I'm left with x equals negative 1. X equals negative 1. All right, and finally our last method, looking inside. Excuse me. So, sorry. Let's ignore everything in here and think about what will complete this problem. 2 times something equals 4. So what should this question mark be? 2 times what equals 4? Well, I know that 2 times 2 equals 4. So whatever has to be inside the parentheses has to be equal to 2. Since I'm able to slot in 2 into this equation and make it true, whatever's inside here has to be 2. So that x plus 3 has to equal 2. And from there we can solve. If I subtract 3 on both sides, I'm left with x equals negative 1. So again, notice that for all 3 problems, even though we solved them different ways, we still get the same answer of x equals negative 1. All right, let's go over our last set of examples. So let's use our distributive property to multiply this out. So I have 4 groups of x minus 1. So I have an x minus 1. Oops, that's not a minus 1. There we go. And I want 4 of these groups, so times it by 4. So 4 times x, notice that I have 4 rectangles, I have 4 x's. Right, and then 4 times negative 1, I'm left with negative 4. So now that I have these tiles, let's use these tiles to solve the equation. You see I have 4x minus 4 here. So one way of getting rid of these negative ones is by adding in 4 positives. Notice how they're going to cancel these out. I can add 4. But whatever I do to one side, I need to do to the other. So let's add 4 to the other side. 2, 3, 4. Right, and I'm left with 4x equals 12. Okay, from there, now we can divide these into 4 groups. So let's divide these into 4 sections. So divide, let's split these up. So if I'm able to split these into 4 groups, I should be able to split these into 4 groups, divide it into 4. So let's see, divide this into 4 groups. An extra one here. Divide these into 4 groups. So it looks like 12 divided by 4. Looks that each section has 3. So 1x equals 3. Okay, so looking at the same problem, let's solve this one, this time by undoing. So instead of multiplying it out like we did for distributive property, what if we just undo this 4 by dividing by 4 on both sides? So divide by 4, divide by 4. That's the same thing as taking these tiles and dividing these into 4 sections. Okay, so divide by 4. But if I divide these by 4, I need to divide these by 4 groups. 2, 3, 4. So I'm left with one group of x minus 1 is the same as 2. From there, to get rid of this negative, I can plus 1 to cancel that out. If I add one tile to one side, I need to add a tile to the other side. So it looks like 1x by itself weighs the same as 3. 2 plus 1 equals 3. Right, which is the same answer we had before. Right, and finally the last method, let's take a look inside. So ignoring everything inside the parentheses, what number can be slotted into this spot so that 4 times question mark equals 8? I think we know that 4 times 2 equals 8. So since I'm able to slot 2 into this position, right, whatever's inside here has to be equal to 2. So I know that x minus 1 has to equal to 2. These two are interchangeable. So solving this equation here, if I add 1 to both sides, x equals 3, which is the same thing we had before. So those are our 3 methods. Here we have 3 examples. So which is an example of rewriting, which is an example of looking inside, and which is an example of undoing. So let's take a look at A. If 5 to the 8x equals 5 to the 24, then 8x equals 24. This is an example of looking inside. I'm ignoring the 5 here, the base. I'm only focusing on the exponent part. And since these have the same base, I know that these parts has to be equal. I'm looking inside the exponent. All right, let's look at part B. Let's see, subtracting the opposite. So that the equation 3 parentheses x minus 7 plus 4, I can start by subtracting 4 on both sides. So you see how they're trying to undo this part? They're trying to cancel out this 4. So that's an example of undoing. And here rewriting. Notice that they're using the distributive property here. 4 groups of 2x minus 3. 4 times 2x is 8x. 4 times negative 3 is negative 12. So they rewrote this using the distributive property. So we have 1c, 2a, and 3b. So let's go ahead and use some of these methods. Again, this time we're not going to use our tiles. We're just going to use the numbers. So 4 groups of 4 groups of x plus 3. So again, we can think of our distributive properly. Right, we're multiplying this height with each of these terms. So 4 groups of x is 4x. 4 groups of 3 is 12 equals 36. Okay. From there, we can cancel out this plus 12 by subtracting 12 on both sides. So minus 12 minus 12. Notice that these are going to cancel out, leaving me with just 4x. And 36 minus 12 is 24. The last step, since I have multiple x's, I can sort these into 4 groups divided by 4. I can take these 24 and sort them into 4 groups. So leaving me with x equals 24 divided by 4 is 6. There we go. All right. Next problem. So instead of using distributive property, instead of multiplying this across, let's go and solve this by undoing. To undo this multiplication, the opposite of multiplication is to divide. So let's go and divide by 5. Notice that these are going to cancel out, leaving me with x minus 2. But again, whatever I do to one side, I need to do to the other. I need to divide this side by 5. And 35 divided by 5 is 7. All right. And finally, last step, to get rid of negative 2, I need to add 2 to both sides. Plus 2 plus 2, leaving me with x equals 9. And finally, for our last equation, looking inside. So I know that since these have the same base, right, if I cover this part up, in order for these two equations to be the same, what does question mark have to be? What does the number in the corner have to be in order for these two expressions to be the same? Since they have the same base, and this part's already 16, whatever goes up here in the corner has to also be 16, right? I should be able to slot in 16 to this spot here and have these two expressions be the same. So since I know that these two have to be 16, I can interchange these, right? 2x has to equal 16. So from there, we can divide 2 on both sides, and x equals 8. So let's answer our focus question. What are our 3 methods for solving the equation? Method 1, we can use distributive property to rewrite the equation. Method 2, we can cancel each term by using opposite operations. And what I mean by opposites, for example, i.e. example, addition cancels subtraction, multiplication cancels division, So those are some examples of using opposite operations. Finally, our last method was looking within. We can look inside and see which part has to match up. Okay. So those are our three methods for solving the equation. Right? If you have any questions, please let me know. If not, hopefully I found these notes or this video a little bit helpful. Right? I'll see you next time.